Okay, now let's look at another thing we're going to do with logarithms, and this is actually figuring out what a logarithm is equal to, actually figuring out its value. Another way of saying this is to evaluate the logarithm for its value. And in a lot of cases we can actually do this just by looking at the numbers and reasoning it out all on our own without using a calculator. So let's start with log base 2 of 16. I want to know, what is log base 2 of 16 equal to? So that's the question here. What is that equal to? Well, in order to answer that question, let's put this as equal to x. And now what we're going to do is change this over to exponential form. So when we change it over to exponential form, I'll swap out the 16 and the x. That'll change it into 2 raised to the x power is 16. And so the question is, what number do we need to have for x in order to go 2 to that power is equal to 16? We know that 2 to the 4th power is 16. So now we know that the x is the 4. And so our final answer here is to say that log base 2 of 16 is equal to that number for x, which is 4. Log base 2 of 16 is equal to 4. Here's log base 7 of 1 over 49. Now let's think about, how are we going to figure out what this is equal to? In the last one I said equal to x, and then I figured out what number needs to go there for x. So the question then is, we got to convert this into exponential form, so we'll swap out that x and the 1 over 49, change it into 7 raised to the x power is equal to 1 over 49. And so what power do we have to raise 7 to get to 1 over 49? Well, that's actually going to involve negative exponents, because 49 is 7 squared, but that 7 squared is in the denominator. So that would be the same thing as 7 to the negative 2 power is equal to 1 over 7 squared. So that's the number that we need for the power, the exponent. So what our final answer would be say log base 7 of 1 over 49 is equal to negative 2. Here's another situation. Log base 25 of 5. So like before, let's say this is equal to x. Let's switch around the two parts so that we change it into exponential form. 25 to the x power is equal to 5. So how can I go from a 25 via an exponent, what value that exponent would take that and change it into 5? Well, we know that the square root of 25 is equal to 5. And roots always have fraction powers that go with them. The square root is the same as a 1/2 power. So 25 to the 1/2 power is equal to 5. So that 1/2 is the power we want for x. So log base 25 of 5 is equal to 1 over 2. Okay, here's another one. Log base 2 of the 5th root of 2. So let's see how this one goes. If I put this as x, and then I swap around these two pieces to go into exponential form, it looked like 2 to the x power is the 5th root of 2. So what power are we looking at when we talk about the 5th root? Indeed, that would be the 1/5 power. So now we see 2 to the 1/5, that's the power we want to use for x. So our answer here would be log base 2 of the 5th root of 2 is just equal to 1 over 5. Another example we'll take a look at is log base 10 of 1 over the square root of 10. So just like before, if we want to go through the full process of figuring this out, we'll use an x. Let's flip these two parts around, make it into 10 to the x power equals 1 over the square root of 10. Now let's change over the square root here. The square root, like we talked about before, was the 1/2 power. So this is the same as 1 over 10 raised to the 1/2 power. And so since that's a 1/2 power is in the denominator, that's the same as a negative 1/2 power. So 10 to the negative 1/2 is the same as equal to 1 over 10 to the positive 1/2 power. So that's the exponent of 10 that we want to use for x. We say log base 10 of 1 over the square root of 10 is equal to negative 1 over 2. Okay, and then one more here, log base b of 1. So how do we figure out what that's equal to? Well, if we use an x, like before, we're going to swap these two things, change it into exponential form. Look like b to what power x is equal to 1. So what power always turns into 1? That was indeed the 0 power. So b to the 0 is equal to 1. So that's the exponent we use. We say that log base b of 1 is equal to 0. 0 is the exponent here. Now here are a few questions to look at for practice after you've seen me work these questions now to figure out and evaluate the logarithms. And if you pause the video here and evaluate these like we did on the last few, and after a second I'll come back and go ahead and show you all what the answers are for each. So on the first one, you can set it equal to x, swap out the 64 and x, change that into 4 to the x power equals 64. And we know that 4 to the third power is 64. So the third power is what we want to use for x, and we say that log base 4 of 64 is equal to the third power. For the other one here, if you set that equal to x, you swap out these two here. What you'll receive is 2 to the x power equals 1 over 8. And keep in mind that the power below 8 to the third power is, 2 to the third power is 8. So we have to be looking at 2 to the negative 3 to get 1 over 2 to the third power. So the negative third power is what we're going to use for x here. And we'll say that log base 2 of 1 over 8 is equal to negative 3. Okay, and then this last one down here, log base 9 of 3, if we set that equal to x, and we swap out these two things here, we'd be looking at 9 to the x power is 3. And we know the square root of 9 is equal to 3, and that's the 1/2 power. 9 to the 1/2 is equal to 3. So 1/2 is our exponent, and we say that log base 9 of 3 is equal to 1 over 2.